Hello class, I, Jaden Palma, will be teaching you about multiple alleles, which can be very confusing for the average person. So buckle up, finish the rest of your tea, and get ready for the roller coaster of emotions that is multiple alleles. Now, I know what you're saying. Isn't multiple alleles just using a bigger Punnet square? And that's where I'll tell you. You are completely and utterly
Wrong.
That is
The definition of multiple alleles is a gene that may exist in 3 or more allelic forms. The most popular example is blood type. Do you know what your blood type is? Well, let's see how you stand in this Punnett square using multiple alleles. Now, I know what you're saying. I don't know how to solve a Punnett square using multiple alleles. Chill. I will teach you how to solve a Punnett square using multiple alleles. But first, let's use another example. As you can see, there are 3 alleles, one being A, the second being B, and the third being O, which is the recessive allele, and AB being the combination of both A and B alleles.
Ejemplo número 1.
As you can see, we have bred 2 different specimens, one being homozygous A, which is Pepe the frog, the other being homozygous B, which is my dog. From here on, you just solve the Punnett square regularly, except the A and B alleles are both dominant, so they combine to make the AB. This means that the offspring will have a 100% chance of having AB alleles. In this case, AB codes for my boy, Jose Dwayne Ricardo Onfroy.
Ejemplo número 2.
Now, from here on out, it can get a little bit tricky. For the last example, we just assumed that both parents were homozygous. From this example, we can see that both parents are actually carriers. Once you stop and absorb the information, you can see that actually solving this Punnett square isn't that hard. You just have to remember that the O allele is recessive, and if the A and the B are put together, they become AB, and neither is dominant over the other. All you have to do is remember that the O allele is recessive, and when the A and B alleles are put together, they become AB, as neither is dominant over the other, and they become their own separate trait. The result of this is a 25% chance for the baby to be AO, AB, BO, or OO. If the baby comes out to be Pepe the frog or my dog Loki, that means that they are a carrier for the O allele. This means that their children might have a chance to become carriers or even possess the trait itself. Thank you for coming to my TED Talk, and I'd like to remind you to keep on sipping tea and slaying.